dum, tick tock, tick tock, tick tock. Here we go. Everybody's joining in. All right. Good afternoon again, everyone. And, it's Matt. After our ordeal this morning, all right, we're back on a stable network. And so I don't know what happened this morning. I heard I had an email a week or so ago that said that they were messing around with a faulty fiber optic cable, and it looked to me like that may have come back to haunt them. But as you can see, I zoomed away from the campus and came back here for the next class. And so this is a good stable network. And so we won't have those kinds of problems now, but it does give us a little less time to cover our topic. But let's see what we can do in the next hour, and we'll figure out a way from there if we need to do any more. All right. So we covered a lot of the important part about basically what we're after with a firewall in terms of filtering network traffic as it comes through. Filtering meaning some we let through and some we drop at that point as if we'd never seen it before, right? And if that sounds a little bit rude or brutal, it is standard practice because, ouch, man, there are so many people that do try to abuse the system. All right. So what I want to do now is I want to start with the enhancement. And I've got a virtual machine running so that we can just quickly go through some of the key points there. All right. There's a complete set of videos that describe the process in detail. All right. Under the enhancements videos, the first section is about IP tables that will kind of walk you through, because this is one of the ones that it's a little bit hard to imagine it. It's easier to get along with it if you can actually see it, okay? So between that and this, we should be fine for this particular enhancement. But again, if you're not doing this enhancement, it's still important to understand these concepts, right? And how this works to protect our system. Whether we're endpoint, I mean, Windows Defender, it's right there. It does the same thing, works exactly the same way internally, a little bit difference in the user interface, but the goal is the same. And the way it's set up to meet that goal is exactly the same. So let's take a look at the assignment first, all right, and then move forward from there. Now, the project resources document is the key one, all right, because that's the one that has all of a little bit of detailed pointers to where all of the resources are. All right. So this enhancement, it says add the rules for noting that proper TCP stack should be processing from the IP tables quick reference. All right. Save the rules to a shell script. Use hping and multitail to show the rules are working. All right. So that's kind of three different parts here. but they fit together very well. Right? Now, maybe what we should do here is first take a look at what it means by things that no proper TCP stack should be processing. Let's back up and review that a little bit. I'm sure that in your introduction to networking class, you talked about this concept of the TCP three-way handshake is what they call it. Let me move down here. This is the PowerPoint we were looking at this morning. We got this far talking about the DMZ, the demilitarized zone. We skipped down just a little bit. All right, to this section called background on TCP. All right, we think about the TCP header. All right, there are 6 flag bits that can be set. All right, and the thing is, the protocol itself, the protocol specification, doesn't use all of these flags. All right, some of them back in the 80s when people were still experimenting a lot and things were less settled, they added some special purpose flags to the TCP header. And over time, over the intervening decades between then and now, a lot of these turned out to be unpopular. Nobody ever used them, but they're still there because they are part of the specification. Right? So they've been added to the standard, but nobody uses them. And people who do are usually up to a little bit of no good trying to figure out what we've got running on our system as a preparatory step to organizing an exploit. In the hack life cycle, they call that reconnaissance phase. All right. So just to say here, right, this is a screenshot from Wireshark, in fact, all right. CWR, ECN, completely unused, never used by anybody, all right. And in fact, most of the time, they are simply ignored, all right, because they were there for a particular extension of the TCP protocol that seemed like a good idea at the time, but over time, it has turned out to be useless. But the same thing with this one that's here that's called urgent, and this other one called push. All right. So here's the thing. There are 6 flag bits, but actually there's 8 flag bits, all right, shown right here in their bit positions, all right, set or not set. They can all be set or not set independently of each other. This is what we call a bit field, all right? So each one has its own significance. But only 4 of these are actually used by the TCP protocol itself. SYN, FIN, reset, and ACK, or acknowledgement. The other 4 aren't really used. And so that becomes a signal to us when we say things that no proper TCP stack should be processing, right? What we mean is illegal or at least unusual combinations of these flags, right? Because there are different kinds of attacks associated with different bit patterns here in this bit field. And some of these, though, are absolutely essential to maintaining proper communication using the TCP protocol. Right? So we want to make sure that those ones that are proper always get through, but we want to filter out the ones that are improper. So how do we tell? Just a little review here. 1, 2, 3, 4. These 4 flags are used by the TCP protocol itself in various combinations. All right. Push, erg, CWR, ECN. All right. It is, again, an ancient protocol enhancement that nobody uses. Push and erg are also equally ancient and unused. So when we push on a little bit here, let's just review what the legal combinations are. Well, the legal combinations being the essential combinations that constitute the three-way handshake and closing of a connection. I think it's easy to see it in the diagram. This is the 1,000 words. This is the picture that's worth 1,000 words. All right. So in order to establish the connection, the host that wants to contact somebody else starts off by sending a packet empty of data with just the SYN flag set. This is a signal to the host B that somebody wants to talk to me, right? So if somebody wants to talk to me and I'm ready to talk to them, I send back an empty packet with both the SYN and ACK flag set, right? And on the other end, I should wait and get back an empty packet with just the ACK for acknowledgement flag set. After that, I start receiving data, all right? And once the data is done, all right, the sender upper who started this connection will send an empty packet with just FIN and ACK flag set. When I see that one, I know that this one is done sending data. I look at my counters and say, all right, looks like I've received everything. So I respond with, again, an empty packet with just the ACK flag set, all right, followed by another packet with FIN ACK set. And the original one when it says, all right, looks like we're all done. We really are all done. Bye-bye until next time. Acts that one. And the connection is closed. All of the memory that it was taking is released. Whatever process was there is terminated. So what have we got in terms of essential combinations of flags? ACK by itself, SYN by itself, SYN plus ACK, FIN plus ACK. All right. Other combinations are illegal. What about fin alone? Fin alone never appears, and so a packet like that is either unintentionally malformed or actually an attempt to play around to see what our system will do when it gets that kind of malformed packet. Right? And so there are a number of attacks that are associated with each of these, but this gives us a guide to what we should always have to let through. Sin alone, ac alone, finac, synac, all right? But other combinations are things that our TCP stack should not be processing. And so that's a really good place to make some firewall rules, all right? They are illegal combinations. They should never arise in the normal course of business, okay? And that's where we want to start. Now, we got a list of some basic ones as it suggests here, right, in the IP tables quick reference. So let's come over to, there's actually 4 pages here on the TinyNet site, all right? One's called Packet Filters Pen Testing, all right? And the IP tables quick reference, the HPing quick reference. Let's just take a quick look at what's HPing. HPing, I just saw the thing here, all right? HPing is a special utility that we can use, right, for what they call packet crafting, all right? And basically what it does, it lets us create a packet with whatever data we want, whatever flags we want set, whatever addresses we want in it. HPing just puts up the blank template and lets us fill in the blanks, all right? Which makes it really good for testing our rules, because if we want to filter certain kinds of packets, we can create exactly that packet using HPing, send it across the network, and make sure that our firewall rule catches it and processes it properly. So that's a very good tool for us. Multi-tail helps us visualize this whole process. So let me switch over to the TinyNet site here first, and let's take a look at the resources we need. Where'd you go? Here we are. All right. Now, right here, packet filters, there's one page called firewalls and another one called pen testing. All right. I have these open in new tabs already. The firewalls page basically is the same as the lecture notes. It's got a little bit from the documentation, all right? Some examples of what the rules look like, right? And what it looks like in the log files. Now, this is the important part for the assignment, right? Because what we're going to do is we're going to set up the rule so that when it catches the packet, it's not actually going to drop it, right? What it's going to do is put a message in the log file for us, all right? So we can check that in the log file, and we can say, yes, this rule is working. And so once it's working, we want to save it so we can add it to our firewall. So we create the rule, and then we can test it with hping, all right? And we'll see some messages like this in the log file with certain details about the packet, right? There's a complete list here of the items that are in that log file entry. So that's the important section, right? This one, IP tables logging, and the rules themselves, we've got examples in a couple of different places. Okay. The pen test, right, describes how our approach to getting our firewall rules working, all right? And this one matches that part that we just looked at. It's got the same diagrams here about the connection, all right? A little bit about hping, a little bit more detail, all right? Multi-tail is explained there on another page. But what this one really offers is a little bit more insight. You know, I said that there are attacks associated with these different combinations of flags, all right? So what there is on this page, pen testing, is here's the hping command to generate the packet, and this is the IP tables rule that should catch it. So there's null scan, syn scan, ack scan. Oops, there's no remedy for these because the syn alone, in ack alone, ouch, man, they're part of the protocol specification. We can't block that. Otherwise, we break our whole TCP connection. But fin alone is illegal, all right? So we can block that one. This one uses the erg push fin, all right? We call it lighting it up like a Christmas tree. And again, we can close that one off. Something that has the same source address and the same destination address. This one was quite a famous denial of service attack on Windows NT in the old days until Microsoft upped their game, leveled up a bit, and closed that one off, but it created all kinds of havoc. Right, so there's a few other ones here that are a little bit about port scanning and attacks, right? But this is our approach, is that we want to create a rule to catch a particular type of packet, and then we use hping to send a packet that matches this rule across the network and make sure that it gets caught. We make sure our firewall rules are working. And if we have more sophisticated firewall rules, that makes the approach here even more important. Now, on the other two here, it's in the quick reference section, all right? Quick reference on escape codes, that's for the colors. Port list, that's just for common ports, common commands. Syslog codes, we'll talk about that a little bit later. All right, but we've got the quick reference for hping2 and the quick reference for IP tables, all right, because these commands can be a little bit cryptic, all right? HPing, all right? Basically, see the man page for full details, but we can get as much detail as we want. We can send 10 packets per second or 1,000 packets per second. HPing doesn't mind whatever our network can uphold. All right. Spoof source addresses, random source and destination addresses. We can set the source port and the destination port. All right. But the one part that is most important to us is setting individual flags in our TCP packet, all right? Because this is the way we create the packet that will trigger our firewall rules. Okay, down here at the bottom of the HPing quick reference, it's pretty, sensible. Minus big F, big S, big R, PAU, all right? On the IP tables quick reference, right, it's a little bit more complicated because, all right, this is one that we need to use all the time. You see this one in the video. This is the one that lists what we've done already, right? And add, insert, delete into our access control list, right? The destinations, accept, drop, the log target, all right, is one that is explained there in the IP tables page. But that's the one that puts the message in the log file, right? The log prefix is the one that we use to just put a label there to tell us where this one came from, and the log level that determines which file it shows up in. And for the source address, destination address, protocol, all right, the TCP flags that we want to catch, SYN, ACK, FIN, RIST, ERG, push, all, or none. All or none is just a shortcut, all right? The one thing, remember, the two lists are separated by a single space, so watch closely, type carefully. And here's the one that was referred to in the assignment. Rules for things that no proper TCP stack should be processing, all right? If all the flags, examine all the flags, that's what this all means. IP tables takes a look at it, and it looks at the whole list. If none are set, that's illegal. So pay no attention to it, all right? SYN, contrary, all right? SYN is for initiating a connection. FIN is for closing it down. So if we look at all the flags and only FIN and SYN are set, drop it. Same thing for SYN and reset, and FIN and reset. FinScan, we looked at that one, all right? We look at just the FIN and ACK flags. If the ACK flag is not set and the FIN flag is set, drop it, all right? And FIN, push, ERG, those are on the pen testing page. So this is just 6 simple rules that make sense, all right? And so we're going to use these to practice writing our firewall rules. And again, these are the kind of trivial ones that are probably going to be taken care of already somewhere else. Right? But they serve us well for examples, and the process that we use to test them, verify that they're working, is exactly the same for these simple ones as it is for all of the more sophisticated ones. Right? The process applies. It's just that these rules are quite simple, which makes life a little bit easier. Teaching us how to use HPing. Yep, okay. It's in the video. If we don't get that far, oops, ouch, Matt. It is in the video. If we don't get that far today, otherwise we'll squeeze a little time in to account for it. All right. The video, where are we at here? Oops. Let me just noodle this one for a minute. TikTok, TikTok. Here we go. Right, in the TinyNet enhancement video section here, walks us through the process. All right. The first one is getting things set up. Setup actually just does that trick that we looked at previously about creating our shell script and having a blank set of rules. All right. And then we create the rule, type it in the proper format. Test and save is where we use HPing to test it, okay? And then we save it to our shell script, all right? So it walks you through one and then two of the rules, and the rest work just like this one. The important thing to keep in mind here is that create rule one is the step that has to be done super carefully, because that's the one where we have to type the whole thing in. All right? You have to type the whole thing in. It's slow and tedious and all that. But once we have it typed in, it's like we were doing before. It's up arrow, and we get it back. We make some little modifications to it. We have a new rule. Up arrow, get it back. Echo and a single quote at the beginning. Single quote, double pointy, file name at the end. That's how we save it. All right? So there's only one step that takes a bit of time and care, and that is typing it in the first time. All right? Same thing for HPing and multi-tail. Typing it in the first time, we have to get it right once. Once we have it right the first time, it's up arrow, modify a couple of small things, and bingo. Knowing the shortcuts makes life easy. Oops. Let me put this down here. Okay. Put this down here. All right, where are we at? Let's see. Okay, so the resources are all there. All right, reminder about shell scripts are simple. All right. Now, I just want to say, to keep the log file small, get the patch ISO in, all right, and run fixconfig.sh on the patch ISO and reboot. I did that already on my gateway here, all right, just to, sure, I've just put it in, mounted it in the devices, optical drives, the patch ISO is on the in the drive, all right? And there's one script there called fixconfig. I ran it. I ran it the first time without a uppercase C, so no such file or directory. Duh. Case sensitive. And it does three things: configuring for smaller log files, adding some new utilities to user local bin, okay, and upgrading OpenVPN and Monkey CGI test. It takes approximately 2 seconds to run, all right, and after a reboot, it will start keeping the log files small, which is helpful when we start filling them up with test messages like this. Okay. So that that will be helpful if you do that. Happen here. I want Alt F2. Nobody, not sure everybody pays real close attention to this, but if you use Alt F1, Alt F2, 3, 4, Alt F5, Alt F6, each one of those, you can get a new separate login screen. Oops, doing that. All right, and you can have a whole bunch of logins at the same time. That's what I have here. I just logged in on this one, Alt F2. This one is my Alt F1, and I just switch back and forth between them. It's very convenient, right? Just something that you might want to remember and try out. All right, so where shall we start? All right, let's start by, let me clear this away. All right, I'm going to type in one IP tables rule. Let me find out which one I want. Oops, not there. Where were they? Here it is. IP tables minus A input minus P TCP minus minus TCP minus flags, all none. Right? That part, right up to TCP flags, is the same for all of these rules. All right? This part here, all none, fin sin, sin rest, all right? That determines the type of packet that we're trying to match, all right? And this minus J is the part that has to be changed. Minus J is not what we want here. Let's see if I picked the right page. Yeah, I did. All right. Oops, wait a minute. Where did it go? Right here in the logging section, all right? What we want to do is use minus J. That's minus J. Doesn't look like it, but that's because the magnification is up too far. There it is. So this is the one I want here, IP tables minus big A input. All right, so incoming packets are going to be examined. Protocol TCP, we want to look at all of the flags. If none are set, then we create a message in the log file, all right? And log level error, all right, means that it's going to go to var log messages. That comes from our syslog configuration. And it's going to have this tag on the beginning, at the beginning of the log file entry, so that we can see the date timestamp, all right, where it came from, who generated it. There is the string that I put into the command, all right, and the rest of this is characteristics about the packet, so we can try to figure out who's trying to attack us. The hping command that triggers this rule and causes this log file to be created, all right, just says hping, that's the name of the program, minus C, think of it as count, all right? So this minus C3 says, send 3 packets, all right, to this IP address, all right? Now, default for hping is null scan, no flag set, all right? We can make it more complicated than this, but we can't make it any simpler, all right? So send 3 packets to this address with no flag set, and IP tables is going to catch those and make an entry in the log file. Let's see if we can do that real quick. IP tables minus A input. Oops, what happened here? There it is. IP tables minus big A. I always try to put a minus there, and I always get a error message. Minus A input minus P. Turn the light on here. TCP space TCP. Minus TCP minus flags. Flags. All. Case none. All right. And then it's minus J to say jump to this action target, minus J log. And, ooh, let me just check this real quick. Minus J log, minus log minus level error, minus log minus prefix. Oof. Minus log minus level error. Don't bother with it. It will wrap around because it's long, but we just carry on typing. Minus log minus prefix. IP tables. No. IP tables. Null scan. Yeah, second. All right. I'll put that there. I'm going to put a space because it's going to look nicer. All right. And use double quotes around that string. And enter. Oh, no news is good news. Let me just jump back here and refresh my memory. I had the IP tables quick reference over here, right up at the top, very first line. IP tables minus big L minus line minus numbers. IP tables minus big L minus line minus numbers. All right. So here it says on my input chain, I have one rule, number one, with the log target that says TCP flag, sin, fin, push, erg. All right, everything before that slash all got translated into the whole list. And then it says none. All right, so examine all those flags. If none are set, then make a log entry, right? A log level error and the prefix. There is nothing in the forward chain, so on the gateway here, anything that's supposed to be passed to another interface just goes through. We don't have any rules. Outgoing traffic, not examined, no rules. So, all good. Let me try this. hping minus C space 3 192.168. I'm working on my gateway 56.101. 1, 2, 3, and stop. So now what happens? All right. Now we need a little bit of prior knowledge. All right. IP tables, when we say log level error, is going to create that log message in the file called var log messages. So I could start up MC, but I'm in a rush. So I'm just going to say tail var log messages. All right. And, look how nice of that. HR timer interrupt took this many nanoseconds now. But never mind. There are my IP tables rules. All right. So my test was successful. I can see that because it says SACN, which nobody would spell scan that way. Okay. Now, while I've got this here, I just want to show you one fun thing. All right. One of the, the utilities on the patch ISO here. One of the things that patch ISO does is it gives us this script called MSG2 syslog. All right, that's mentioned at the very tail end of the enhancement on the assignment. All right, MSG2 syslog. I'm just going to try it and say, let's just try it and see what happens if I just do it this way. MSG2. Oop, parameter error, -1, ouch. All right, let me just, I'm going to MC this one up. In user local bin. After I do the patch, F3 for a minute, all right. Facility is user current mail daemon, auth sysnews on, auth priv. Priority is error. All right, facility is kern, and priority is error. All right, send a message to the local syslog socket. Kind of bare, but everything is up to you. All right, FC PC. Okay, we got it, we got it, we got it, we got it. Message to syslog kern has to be uppercase, error, and let's say hi. My messages. See what happens. There we go. Sending with code 0 + 3 = 3. Hey, there it is. Right down there. You can see it, that very last one. User local bin message to syslog 1365. Hi, messages MC. Okay, so that way you can create your own message, and sometimes it makes sense to put in something like so you can tell what you're doing. This is the real purpose of it, all right, is to be able to put a message like this in the log file, all right? So you can tell if it's just your testing, all right, or if it's something different, all right? So if you put an iptables testing message like that in between each one, you could make it a little bit more interesting if you like, all right? But that's what the last part there that says extra credit is about. Okay, we run out of time, sadly enough. I wish we had our whole lecture this morning, but never mind. Hopefully that was a one-time thing that is not ever going to